All right, 7.4. All right, so it says in any rhombus, JKLM. So remember, rhombus is when all four sides are equal. That doesn't really look very good. That looks more like a kite, but it is a rhombus. So JKLM. Determine whether these are always or sometimes true. Well, L and M are these two angles here, right here. Now, in a traditional rhombus, they don't necessarily have to. Like if we're looking at a classic diamond rhombus, those are not the same. But if we're looking at a square, which is also a rhombus, they are both 90 degrees, so it would be work out. So we go with sometimes. JM and KL are equal. Well, that's always because all four sides are equal on a rhombus. And JL and KM, so JL and KM are the diagonals, and not always, but sometimes. Okay, find the measure of the numbered angle in the rhombus. Okay, so we're trying to find 1, 2, 3, 4, 5, 6. Okay, well, if this is 27, then angle 4 is also 27. Therefore, 1 and 2 on the opposite side are also 27 themselves. Okay, now on the inside where they cross, the diagonals cross, that is 90 degrees. Okay, now let's think about this. If this is 27, that means this is 54 and this is 54. Okay, that's 108. So if we take 360 in a quadrilateral minus 108, that gives us 252, which we have to divide two ways and get 126 here and 126 here. But then we have to divide that by 2 again to get these two of 63. Okay, so again, first off, we found out 54 and 54, which is 108. That means there was 252 degrees left between the two opposite sides, or two opposite angles, D and F. Then we had to split them, and then split them again to get the two bisected angles. Okay, over here we have 1, 2, 3, 4, 5. All right, so 106, this is going to be 106 also. So 5 is 106. So again, we combine that. That means we got 212. So if we do 360 minus 212, that leaves us 148. But we have to divide that by 2 again to see that's 74 here and 74 here. And then we divide all those by 2, we get 37, 37, 37, and 37. Okay, for any rectangle, WXYZ. So a classic rectangle, WXYZ. Well, if it's a rectangle, then all the angles are going to be 90. So this is always. WX and ZY, WX and XY. Well, WX and XY are perpendicular lines. In this classic rectangle, it's not. But if it was a square, which is also a rectangle, then it would be true, so sometimes. Classic rectangle, no. Square, yes. WY and XZ are perpendicular. Well, those are the diagonals. If it's a classic rectangle, no. If it is a square, then yes. So sometimes. Is it a rectangle? No. because they are not all the same. But it is a parallelogram. Because both opposite angles are equal. So this could be like 91, 91, 89, 89. Really close, but not exactly. Opposite sides equal. 90 degrees. Yes, it is. Okay, find the lengths of the diagonals. So, again, with diagonals, which WY and XZ are diagonals, they are equal to each other in a rectangle. So 6x minus 7 equals 3x plus 2. Now notice it says find the length of the diagonals, not just solving for x. So if I subtract 3x, I get 3x. If I add 7, I get 9, so x is 3. But then I have to plug in 3 here and here. So 3 times 3 is 9 plus 2 is 11. 18 minus 7 is 11. So each diagonal is 11. And over here, 24x minus 8 equals, notice it's a negative 18x plus 13. So I'm going to add 18x and get 42x. I'm going to add 8 and get 21. X is 1/2. But again, I need to plug it in for x. So 24 times 1/2 is 12, or divided by 2 is 12. Minus 8 is 4. And again here, this would be negative 9. 13 minus 9 is 4. So each diagonal is 4. Okay, name each quadrilateral. Here are the names we're going to use. It is equiangular. Okay, that means all the angles are equal. That's going to be a rectangle or a square. Works for both. It is equiangular and equilateral. That is just a square. The diagonals are perpendicular. That happens in a rhombus and a square. Opposite sides congruent. Well, that's a parallelogram. That is also a rectangle. That is also a rhombus. And that is also a square. The diagonals bisect each other. That's all 4. I'm not going to write them all down. That's all 4 again. And the diagonals bisect the opposite angles. That's only in a rhombus and a square. Right. We have a rhombus, ABCD, intersecting at E. Given that BAC is 53, and DE is 8, and EC is 6, find the rest. So DAC is going to be also 53, because A and C are bisected. AED is going to be 90, because the diagonals are perpendicular in a rhombus. ADC, that's the whole thing. Okay, so you got to do a little work here. This is 53, that's 53. That means this is 106, which means this is 106. So that's 212. 316 minus 212 is 148. Divided by 2, that's 74 here and here. So ADC is 74 degrees. ADB would be 37. DB is the whole length here, so that's 8 and that's 8, so that's 16. AE is going to be the same as EC, so that's 6. And AC, the whole thing, will be 12. Okay? So here we have a rectangle. So we know all of these are 90 degrees. Okay? if this is 34 right here, then 90 minus 34 is 56. Okay, and opposite interior angles, this is 56, this is 34, this is 34, and this is 56, and this is 56, and this is 34. Okay, so QTR is 56. QRT is going to be 34. SRT is going to be 56. QP, well, we don't have any numbers right now, but we know QS is 10, so QP is 5, and PS is 5. RT is 10 because diagonals are congruent, and RP is going to be half of that at 5. Okay, now notice we have a square. So MKN is going to be 90 because the diagonals are perpendicular. LMK is going to be 45, half of 90. Okay, LPK again is splitting the 90, so that's 45. KN, well, if this is 1, this is going to be 1. LN is 2. And MP is going to be the same because diagonals are equal. All right, 65 through 70, we're using one of these three words. A square is always, I'm just going to put the first letter, always a rhombus. A rectangle is sometimes a square. A square is always a rectangle. A rectangle always has congruent diagonals. The diagonals of a square always bisect the angles. A rhombus sometimes has 4 congruent angles, if it's a square, and a rectangle sometimes has perpendicular diagonals, okay, if it's a square. And last but not least, we're going to put these on here, JKLM. So J is negative 4, 2. K is 0, 3. L is 1, negative 1. And negative 3, negative 2. And here is our shape. All right. And we have J, K, L, M. So we're going to find the slopes of all these. So the slope of JK is up 1, right 1, 2, 3, 4. So 1/4. And ML is also 1/4. Now JM is down 1, 2, 3, 4, right 2. So the measure of JM is 1, 2, negative 2, and KL is the same. Now, we'd have to do distance formula to find all the lengths, so the easiest way is actually to go with the diagonals. Okay, so we want to find JL and KM. Okay, so the slope of JL is negative 3/5. And the slope of MK is positive 5/3. So what we know is that these are perpendicular. So we know the diagonals are perpendicular. Now we just have to do the distance between KM and JL. So that's the distance formula. But we only do it twice instead of 4 times. So that's nicer. So I'm not going to do the whole distance formula for you, but it is, remember, the square root of x minus x squared plus y minus y squared. And you'll find out that the distance on both of them is the square root of 34. So we know that this shape is a rectangle, a rhombus, and a square. It says all the names that apply. And last but not least, 3, 1 is right here. 3, -3 is right here. 2, -3 is right here. And hold on. 3, 1, 3, -3. Oh, sorry. That's to be -2. -2, -3 is right here. And -2, +1 is right here. So we have this shape right there. Okay. And the nice thing about this is we know we can measure the lengths. So the length of this side is 1, 2, 3, 4, 5. The length of this side is 5. This side is 1, 2, 3, 4. And this side is 4. So right off the bat, we know it's not a square. And it's not a rhombus, because the sides are not equal. Now, since we can look at this and know that this has a slope of 0, this has a slope of 0, this has a slope that is undefined, and this has a slope that is undefined, we know that these are perpendicular, so we know it is a rectangle. And that's it.